Hey, this is Randy. Today we will review real numbers versus imaginary numbers, and then we'll talk about complex numbers. More specifically, how do we identify different parts of complex numbers? And lastly, we'll talk about how to represent a complex number graphically. Let's do this. So here we have two lists. Let's first talk about this list of real numbers and make some observations. Notice that a real number could be positive, like 1, or it could also be negative, like -5. Now, a real number could also be a repeating decimal or any other decimal like 0.5 or 0.8. So here we have 0.6 repeated. There's a real number. Also, something like pi is considered a real number. And lastly, even a fraction is considered a real number. Now, let's look at this list down below of imaginary numbers and make some observations. Okay, well here we have I. What's another way to think of I? Well, it's like saying 1 times I, right? Just like the second example is -1 times I, or you can just say -I. So what are we seeing here? Well, an imaginary number is actually a real number times that imaginary unit that we call I. Now we know that the imaginary unit is defined as the principal square root of -1. Principal square root of -1 is equal to I, right? Just like we know that I squared is equal to -1. So you could also have a bigger number like 18 times I. There's an imaginary number. You could also have pi times I, and even like a fraction times I, 12 over 13 times I. Okay? Now, what happens if we take a real number and we add or subtract it with an imaginary number? Well, that's going to give us what we call a complex number. So let's talk more about that. We have lots of examples here, and we'll talk about each one. So 8 plus 3i, notice that both of these are positive. There's one example. You could also have the imaginary portion negative. We have 9 minus 2i right here. Now, the imaginary portion could also come first, so you could have something like -2i plus 1. And they could both be negative, like -6i minus 7. Okay, now let's look at this last example here, and you'll notice that it's set equal to z. Okay, z is a common variable you'll see when dealing with complex numbers. So here we have z is equal to -3 minus 5i. It's common to see the imaginary portion second, just like in this example. So if I asked you, what is the real part of this complex number? Right here, the real part is -3. Okay, you could also describe that by saying RE parentheses Z is equal to -3. Okay, that's just saying that the real part is -3. Now, this next question is a little bit more complicated. If I ask you, what is the imaginary part? Some people would say that it is -5i. But the imaginary part is actually just -5, because if I ask you, what is the imaginary part? That I is already implied, so we don't say it, okay? So we could say that the imaginary part is -5, or we can say, just like right here, I m parentheses z is equal to -5. Okay, next question to think about is, how would we represent something like this graphically? And that brings us to something called the complex plane. Now, you're probably used to seeing a coordinate plane with a vertical axis that is y, right? And a horizontal axis that is x. So when we use the complex plane, we replace that y-axis with im, which represents imaginary. So it's the imaginary axis is the vertical axis, and re for x, which represents the real axis. So if I take a number like that one that we just had, this complex number -3 minus 5i, and I try to graph it on the complex plane, what would that look like? Well, let's go step by step here. So there it is, -3 minus 5i. We're going to start with the real portion, -3. That's going to tell us to go left 3 units on the real axes, okay, the horizontal axes. So we're going to start at the origin, 0, 0, and go left 3. So it's going to be like this, 1, 2, 3. And then this -5i will tell us to go down 5 on the imaginary axes, that is vertically. So we're going to go from here and go 1, 2, 3, 4, 5. So right there. And we're going to write these lines here. 1, 2, 3, 4, 5. Just like that. So that point right there is the graphical representation of the complex number -3 minus 5i. Now, what happens if we have, two positives or just one of them is negative? Let's talk about that. Well, if the real portion is positive, then we're going to start by going right. And then if the imaginary portion is positive, such as let's say that we had plus 5i, then we'll go up after we go to the right. Right? So left is negative, right is positive, down is negative, up is positive. All right? And with that, we are finished with the video on parts of complex numbers. See you next time.